Remember that the reason Athena is creating all of these box models in the first place is for her architecture internship. So that means that when she's discussing functions like this one, she's probably going to want to focus on the values of the domain that make sense in the physical situation she's discussing. We figured out before that if Athena wants to make sure that she's actually able to fold her piece of paper into a box, x should be greater than 0, but it should also be less than 2.5 inches. However, we saw that if x equals 0, then the volume equals 0. And if x equals 2.5, the volume also equals 2.5. The idea of 0 volume is actually pretty understandable. It's negative volume that's the issue. So I'm going to go ahead and decide to include these endpoints in our domain. So here we go. This is the domain of the function that we've decided upon, using our common sense to deal with the situation at hand. So like we talked about in the last lesson, this is not a mathematically imposed domain restriction. This is one that we're imposing upon the equation ourselves to make the equation better fit the situation of the box. So let's visualize this with a graph using this domain restriction. So here's what a graph of this function looks like with these domain restrictions put in place. We can see that the graph is only allowed to take on values of x between 0 and 2.5. And as shown in this inequality, our interval includes these endpoints, so there are closed circles at either one.